Good day, my name is Franja van den Heever and this is my EAL3601 Alternative Energy Design project. The following presentation will feature the alternative energy design of a rural hospital in Kwakwa. An overview of the following presentation will contain the topics Introduction, Objectives, Delimitation, Research and Background, User Requirement Specifications, Design and Methodology, Project Costing and References. Introduction. The project aims to design an alternative energy-based energy system for a rural hospital in South Africa. The layout of the hospital is provided by UNISA, and UNISA will be considered the client in this regard. The project specifications are provided under the EAL3601 module resources. So the project specifications were taken from the MyUNISA site and referenced accordingly, and those specifications were adapted to fit the project descriptions and outcomes. The project has the following objectives. The first objective, research applicable areas of alternative energies as a foundation to the project. Without prior research, nothing can be designed factually. Objective number 2, design an alternative energy off-grid power system that can provide power to a rural hospital in South Africa. The project requires that the energy source of the design should be alternative energy, and whichever type it may be, the project also suggests that it should be preferably it should be a solar energy design. Using the exact source power requirements, size the system and establish the required kilowatt-hour capacity for the hospital's power plant such that it meets the established requirement. So the system needs to be compatible with the hospital and the electrical system demands of the hospital in question. Then also draw a detailed layout of the design. This is the CAD component, so that if the design should be implemented, the contractors may know where to place what and what the specifications and standards are that will be adhered to. Compile the design, CAD drawings, single line diagrams, calculations, etc. into a final report. So all of the components, finally research, design, methodology and user requirements will be compiled into an academic report. After the project completion, review the report and reflect on whether the set objectives and desired outcomes were reached. Also provide possible improvements and shortcomings to the final design. So after the project was designed, in the academic report, all of the outcomes are evaluated and it is established whether the objectives and user requirement specifications were reached. Project delimitation. This section focuses on what will not be done in the project. So what are the limits of the project in terms of what will be provided and what will not be realized within the project. The following points will not be addressed or done in the project. So the first delimitation point is the project will not be installed or built as a prototype. And secondly, some of the construction features will not be included in the costing of the project. So this is simply a theoretical project. It's an academic project, so it does not have to be implemented in an actual location or rural hospital. And secondly, the construction of the project in terms of building materials and construction layout and scale of construction is not going to be completely addressed in terms of costing and specifications. Research and background. Before the project design commenced, various points of interest to the project were researched to establish a foundation for the project design. The first most important part of the research was a look into alternative energies, of which the first is solar energy. So solar energy is a renewable type of energy that consists of using solar PV panels to harvest energy from the sun, and that energy, light energy, is then turned into electrical energy via solar PV panels. The next source of energy is wind energy. Wind energy uses wind turbines and it turns wind stream energy through mechanical energy into electrical energy. Next, we have geothermal energy. Geothermal energy is a type of energy source that uses thermal energy from the Earth's inner core to generate electricity. Then we have hydropower. So hydropower can be either run off river or it can be reservoir based. And hydropower is using gravity-built dams and reservoirs to use water flow in order to generate electricity. Ocean energy is a form of energy that uses underwater turbines and utilizes the currents in the subsea ocean area to generate electricity. This is still a very new form of alternative energy, and further details can be found within the project report. Bioenergy is a type of alternative energy that uses biomass, and biomass is then turned into heat energy, and this is converted to electrical energy. Solar PV for hospitals in Ghana. One of the topics that were looked into was an article about implementing solar PV for hospitals in Ghana. The following points were addressed. First of all, it was found in this article that solar implementations in Ghana that were already successfully done can run critical systems continuously. So in other words, there's a backup. If there's a power outage, then solar PV can successfully run critical systems such as life support and ICU-based machines. It's a lower cost solution than a generator-based system, so a fossil fuel generator was found to be more expensive than solar PV. And one of the other parts that this article investigated would be organic PV panels, OPV panels. This is still a new development. However, organic PV panels are much more friendly to the environment and can then be used in solar installations. It was also found in this article that organic PV panels can even be more efficient than poly or monocrystalline panels, the conventional panels that we are using today. And this is still a point that will need to be further researched. And then hydropower was also looked into as a possible solution, since it is a very effective form of alternative energy. So consider small-scale hydro power plant as a possible solution. The particular plant that was looked into is called a run-off-river type of plant, and it looks like this. So a run-off-river plant is not a reservoir-based plant. It is a dynamic plant, so you do not need to store water and then release the energy when it's required, like with a dam project, a hydro dam project. The run-off-river project looks like this. It has an intake upstream, and then there is a canal and a penstock. The penstock takes the water downstream, and then at this point, due to gravity, the water flow has established enough energy to rotate a turbine in the powerhouse, and that turbine then generates electricity through a generator, and that can then power a house or a rural community or a rural hospital in our case. So consider small-scale hydropower plant as a possible solution. The particular study and references to this study is the Kwamadiba small-scale hydropower plant on the Tina Falls area in the Eastern Cape. The small-scale hydropower plant can be more feasible financially than a grid connection to a rural area. What this means is that in some cases, extending the existing grid to a rural area is more expensive than just simply implementing a small-scale hydropower plant, such as a run-off-river type plant. Solar PV will be used since there is no guarantee of a viable river source near the hospital. So the reason for choosing solar for this project, ultimately in the end, solar PV was chosen, is just simply because there was no specification provided that there is in fact a viable source of water or river flow near the rural hospital that's being designed for. But we do know that there are good sun hours in South Africa, and particularly in the Eastern Cape. So solar would be a viable option. So types of solar PV systems were also considered. Three types of topologies were investigated. Grid-tied, off-grid and hybrid. So a grid-tied system is a system that usually does not feature battery backup. So it's simply a system that during the day you can directly use solar from the PV panels, and any excess power generated can, in some cases, it's not always the case, but can be exported back onto the grid. And then the user or the person owning the solar plant is then reimbursed for this power that is exported back onto the grid. This is called grid exporting. So a grid-tied system is a very economical system and can greatly reduce the electricity bill. The next type of system is an off-grid system. This is a fantastic system if there is no power from the grid available. And this particular project is an off-grid system, because we do not know what the condition is, if there is any grid provided to this hospital. So the aim of the project was to design a completely off-grid system that can provide a full-scale solution 24 hours a day. A hybrid system is a combination of a grid-tied and off-grid system. So off-grid system will usually feature battery storage or generator backup, so that in the night time, or if we have rainy days, there will still be power provided, so that if there's no solar power from the panels, there will still be a backup source of power. The hybrid system will usually have a grid tie incorporated with an automatic transfer switch, and can be switched between the grid and the solar, or even battery backup also. The user requirement specifications of the project. So these specifications were basically compiled from the requirements provided by UNISA, by the EAL3601 module content, and also considerations were made just towards the practical requirement of the project and what needed to be done. There are 10 user requirement specifications, and there are further details on them in the report. So, design a complete electrical system source to load for a rural hospital in the Eastern Cape that is based on an alternative energy solution. So the project must use some form of alternative energy. The medical facility and warehouse section should have their own separate three-phase power supplies. So the warehouse must have its own distribution board and its own dedicated three-phase power supply, which we will look at in a moment on the electrical drawing. The intensive care unit, ICU, should have a constant power supply with redundancy to ensure no downtime. So the ICU is considered a critical systems area, and we always want the life support machines to be functioning and on. So the ICU was prioritized in terms of generator backup and battery storage in the case of this project. Consider all necessary safety precautions to ensure that the design meets the required certification. So the SANS standards were used in this project and investigated to a certain extent to ensure that at least a single line diagram and the layout and placement of fuses and safety junction boxes were in the right location, and that the system would adhere to national standards in South Africa. The COC certification is a certificate of compliance. This was not done for this particular project, but if the project were to be implemented, a COC needs to be written out for the project to certify the project as being a legal electrical installation in South Africa. Load voltage may not deviate at the load, 6% for single phase and 8% for three phase. So basically we do not want a massive surge or deviation in power. The project needs to provide stable